Okay, yeah, welcome back to Introduction to Mathematics. Today I'm gonna talk about mean random variables. Really, another expression which illustrates the same meaning is expected values. I have seen that most of the students they are really shocked with this term expected values. Let me show you what does it mean by expected values. Right, it's really pretty much easy to understand with the simple ordinary meaning of mean of random variables. Right, okay, so if you have a set of data point, a set of events, uh, if you need to find out the mean of random variables, what you have with you, so what you need to do, I'm just talking about arithmetic mean. We need to get the summation of all the way from first to last. Let me assume that I'm having n number of events, right? So this is my arithmetic mean. We know it's up to our sample. This is a sample which was extracted from a population, and that's why I have denoted it with x bar. Otherwise, we need to use mu, right? Suppose that this is a discrete random variable. Suppose x to be a discrete random variable, and it induce sample space x1, x2, such as it's continued up to xn, right? Sometimes this might be finite. Sometimes you may know exact values in this sample of population. If you don't know what about the population, or what about the exact number of events in your sample of population, what you can do is you can repeatedly generate with your true values, right? It means you can synchronize your situation and you can generate some samples, some different kind of samples with these existing values, right? Okay, I'll show you how to do it in my further videos, right? Please, if you don't have an idea about discrete random variable or continuous random variable, what's the contrast between them, please I suggest you to go to our previous video sessions and go there and please just study, right? Okay, by there I'm gonna explain it. So simply it looks like this one. So the same meaning will be expressed with expected value. There is nothing contrast except the these terms what we're going to use, right? At this moment I'm going to talk about discrete random variables. So the probability mass function will be look like this. So I have picked simple probability mass function, right? So height of these bars will represent each of their probability masses. That is proportion to what? This is directly proportion to each of their probabilities. And let me just pick this is x1, right? Here, okay, x1. Let me just show you everything, right? X1 plus delta x upon 2. Right, okay. PMF is multiplied by delta x, which is the width of this bar, right? So then you can find out this probability. So this is nothing as the probability which is related to this bar I have selected, right? Okay, so there is a proportion. What you need to find out is all of the summation from first one to last. So now you can see I'm going to show you the most convenient way, right? We have sort of ways to simplify and express the same idea. Let me clean this space, right? So with this bar, or with this bar, what I have selected in my previous case, right? Okay, so this is what, let me show you once again. This is here, really this case x1 minus delta x upon 2 upper x between, in between x1 plus delta x upon 2, right? This is made of at probability mass at that point, probability mass, not probability density, right? Probability mass at that point times delta x. Okay, so we need what expected values, which is denoted by ex, right? So let me show you how we can generate these expected values, right? Okay, this is the probability. Uh, Probability is nothing as if your sample size is upper n. We can write down these probabilities as this corresponding frequency. Let me just pick some corresponding frequencies with little n, right? So by little n1, his corresponding frequency will be denoted, right? Okay, then there is a proportion little n1 upon upper n. This is the probability. This is what the probability, right? So this is what the probability times her frequency, each of their frequency. Here must be this should be corrected as this is the probability. That's all right, right? So and our discrete random variables are denoted by xi. So the corresponding random variable is xi. Once you get the summation such as n2 upon upper n times x2, this guy acts like frequency, right? That's the frequency. So it is continued up to n1 little n, and that is quite different. Quite strange because little n n1, right? This is for nothing else for representing frequencies. This is continued up to xn. This is the final data here, right? Okay, so now what we can do here. This is each of these things what I have written over here. These are frequencies. These are these are probabilities, right? These are probabilities. So these probabilities can be written. These were compulsory representing this idea. So now we hesitate to put these upper x because it's supposed this discrete random variable, right? At that point exactly times x1, right? Okay, so just like that, px x2 times x2, right? So it is continued up to px xn times xn, right? This is what the expected value of mean of random variables. You know, mean of random variables. This group frequency distribution, which is classified under discrete random variables. So frequency times the corresponding data, corresponding class sign. Get the summation all the way from first one to last one, and divide it by whole number of events they have concluded, right? Okay, so this is what we have clustered, we have bind together, so it creates the probability, right? So once we multiply this probability with its own corresponding data, discrete and a variable, you can see now this can be concluded with this can be written as expected value of this random variable can be written as with summation summation probability xi times xi. Let me write it down over here, right? It's better. I is from 0 to here. I is up to the usage what we apply. So it will be discussed once we go furthermore. So briefly we can say or present this expected value as summation xi times the probability, right? Okay. So we have used this proportion with this probability mass function. So keep that in your mind thoroughly, right? Okay. So thank you for watching. I'm Sapuman Sena Deroge Sasangasagar.